Hey, bud, do you want to play a game?
Totally.
How many batteries do you see over
Well, I've got my phone, my watch, your phone, and that camera. So 4.
here? I think that there are 40,000 batteries over here.
40,000. What do you think a battery is, anyway?
So what are these ambient batteries? These ambient batteries are nothing but easily harvestable energy sources that are available all around us and have stable and deterministic voltage and current characteristics over a long period of time of the order of months or decades. So what has changed that has made it possible that we can look at these energy sources again, or why have we overlooked at them? And will they usher in a new age of deployable systems? Are all the sorts of questions that we wish to answer in our presentation. What do we want to do with these ambient batteries? With these ambient batteries, we want to design energy harvesting systems for high level applications. Now, what do these high level applications look like? With the advent of smart cities, there are a number of high level applications, such as simple monitoring applications, which can involve, say, measuring the structural health of this bridge, or the vehicular traffic, or the foot traffic on this bridge. Now, what should these systems look like? Now, these systems should be autonomous in operation, requiring low maintenance burden, especially the maintenance associated with powering these devices in these systems. Now, this is especially important for those applications where we want to know nothing exciting has happened. So, in say somewhat boring applications, but we want to know reliably that nothing exciting has happened, which is important when we look at these large scale, large deployed systems where we exactly have to know when the maintenance is to be done and whether a sensor is operating or not. So, reliability of a system depends upon the reliability of the energy source. This reliability, in turn, is determined by the predictability and the availability of this energy source. Now, if your energy source is not reliable enough, then you have to resort to complex intermittent computing solutions, which are mostly complex software and hardware solutions, to mitigate this problem. But instead, if we could find a reliable energy source which works or which we know is available over a deterministic period of time, then we can shift the problem associated with intermittent computing to finding this energy source, which will just make life easier. Let's understand what are the major components of an energy harvesting system. So traditionally there are four major components. That is an energy source, which can be solar, thermal, or ref, an energy buffer where the energy is stored, that can be a supercapacitor, bank, or a rechargeable battery, and charge controller, which can be a custom or a commercial circuit that deals with the power management functions that are needed to boost the input energy to the appropriate levels, or to rectify those energy levels, or to track the maximum power point of those of the input energy. And then we have the energy consumer, which is nothing but the application circuit, which will consume this energy that we have harvested. Generally, these energy consumer circuits execute simple sense and send events, which is sensing, that is measuring the parameters and sending the events to the user over some communication protocol. So now let us understand what has changed in these energy harvesting systems. So the components themselves have not changed. The components still exist. What has changed is the characteristics of these components. So for example, supercapacitors have more or less the similar effective energy volume over their entire lifetime as that of any other battery. At the same time, the power management functions or the charge control functions, which were generally custom designed circuits, have now been replaced or modularized into single commercially available energy harvesting ICs, which operate at very low input powers or input voltages and currents. Similarly, the energy consumer side of it, the microcontroller circuits or the radios that are used to transmit this data, themselves have started consuming very low powers. So we see there is a large optimization on on the rest of the three components of a typical energy harvesting system. So now what has happened is all of these advancements or all of these developments have now allowed us to look towards those energy sources which earlier did not have sufficiently high enough instantaneous power to be harvested or to do any work with, right? So now that we look over here is that we have the simple setup that is built where we are harvesting energy of a galvanic corrosion cell, which is nothing but a magnesium electrode and a stainless steel bucket with water as electrolyte. We have hooked two wires to it, and then we are powering our entire system. So this galvanic or this corrosion battery acts as an energy source, while we have the supercapacitors which act as the energy buffer. We have the energy housing IC which will act as for the power management functions of the device, and then we have the microcontroller and the radio or the transmitter module which will allow us to measure the health of this electrode and send it. So before we start discussing or finding these reliable sources, right, we need to know how do we categorize our energy sources right now. So energy sources can be categorized in three broad categories. They are impulse sources, concentrical sources, and periodic sources. So, what are impulse sources, right? Impulse sources are anything or any energy source that generates energy when an event has happened, right? So, that can be something like footsteps, that can be something like door opening or closing. So, generally, these events generate energy, and that energy can be used to tell whether an event has occurred or not, right? But the drawback of this is that when this event has not occurred, you cannot identify whether the system is working or not, or you cannot identify like if the sensor has broken or not, because there is no way of getting validated information as to if the system is working well. So, what are the second type of commonly used sources that we use in energy housing? So, one of the most common one is solar. Like if you look at this over here right now, like we are here in the evening and the sun has set down, right? So the sun is up there for like whatever 5-6 hours. We get energy there from it, but once it sets down, we don't have an energy source available to us. So the third energy source, which is the more interesting one and which is what you want to focus on, is the constant trickle energy source. So now if you look over here, it's something like this corroding piece of metal, right? So this corrosion process itself is something that keeps on occurring regardless of, say, time that we see right now in the evening, or regardless of an event or an event trigger, but still it keeps on occurring and generates energy. So now the question comes is, can we use these ever-present phenomena and use this like low power energy that is being generated or low power batteries to power a reliable energy housing systems?
Wait, this is totally crazy. Are you saying that like everything is a battery?
Well, not everything. There are some rules we have to follow. Like, for like, these are batteries, those are batteries, the trees over there are batteries. So that's the first rule. So, what is the first rule of fives? The first rule of fives is that the energy source must be available in at least 5 places, or should be readily available all around us in the environment. But at the same time, which implies that the physical phenomena that will generate this energy source should not be an obscure physical phenomena like a geothermal energy, which is only available in certain locations, or beta voltaic radiation sources. Uh, but at the same time, the energy source should not be too generic enough where we cannot estimate how much energy would we be able to harvest from these sources. So trees are a good example of these reliable energy sources because they have a constant energy internal temperature of 21 degrees Celsius. So that means that regardless of whichever species, regardless of wherever you're on the earth, you will get an internal temperature of about 21 degrees Celsius, allowing us to harvest this thermal energy from these trees reliably. So now when we come to the second rule of our systems is it should be easy to install. So if you look over here, we have as an earth battery, right? Now the earth itself is a massive source of energy which has multiple effects occurring at the same time. You have the galvanic corrosion effect that's happening. You have microbial decay processes that are happening. You have telluric currents that are flowing, which are caused due to magnetic fields of the earth interacting with the cosmic radiation. So all of this energy can be harvested, and all you need to do that is just like take two electrodes. Like right now I have magnesium electrodes, but they can be like zinc, carbon, and based upon what electrodes you select, you just plug it in, take two wires from it, and you can hook it up to your system and it will start operating, right? So that is the second rule is it should take 5 minutes to install as this system. Now let's look at Rule 3. Rule 3 states that $5 materials. That means the cost of the materials needed to harvest the energy from the energy source should be low enough or should be cheap enough so that it does not affect the overall usage of this energy source in any of the deployed systems, because the cost of these materials will affect the overall deployability of this energy source in any of the systems. Rule 4 states that it should take about 5 hours to design. So when we say about 5 hours, it basically means that the overall components that are used in the system design should be simple enough and should be commercial off-the-shelf components. The reliability of the entire system is derived from the simplicity of the design of the system. So as we see over here as well, when we harvest the energy from this corrosion battery or a corrosion cell, we use all commercial components, a simple design, but at the same time a reliable design. The fifth rule that we have is that it should execute for 5 events a day. So when we say 5 events a day, it does not mean to impose a specific interval at which the entire system must operate, but rather it says that the energy source should have sufficient power such that the system can operate consistently and deterministically enough so as to give us reliable information about the parameters that it's measuring or the system health that it is measuring. So with this, we have these 5 rules or these 5 general guidelines, you can say, to design these simple energy harvesting applications.
So, Pat, where do we go from here?
Where do we go from here? We go everywhere. That's what's so cool about all of this. That tree is a battery. That pile of mud right there is a battery. That rusting piece of metal over there, battery. All of these things are batteries. And that means that we have these new, reliable energy sources all around us. And it's really going to change the game for how we deploy systems. And I'm super excited. This means we're going to have tens, 20s, hundreds of thousands of systems that can actually really last and build out reliable, robust monitoring infrastructure for our built environment. This is really cool, Dhananjay. I'm pretty psyched.